So hello everybody. This is one title for my talk, but another alternative would be why I like Gleam so much. So this is me, long story short. I'm a developer guy. I also work in infrastructure, but my work is to uplift teams. And I've been facing the industry for more than 10 years, building web systems SaaS from many perspectives and roles. This is a little bit of agenda, what I'm trying to do. I'm trying to expose to you an idea so you can develop later. However, we can only make our toes wet in this talk with an appointed time. So it's very hands-on and very, I'm trying to show you by example. Okay, who recognizes this book here? Yeah, I mean, I didn't read it myself, but I know that it exists. And everybody talks about it. But domain-driven design is a very good book, and it's a very good idea that was brought forth. And this is the origin of what brings me here. When we talk about domain-driven design, we can distill it in a few things. The main points would be, yeah, let's talk to domain experts, regardless of the business, regardless of the use case and what we want to do. We then try to identify boundaries. You know, you have this called event storming, and you try to figure out with everybody who knows, including the secretary that might know even much than the proper project owners about specific case, and everybody participates and everybody agrees that this is something that makes sense. And we try to separate concerns and subdomains and boundaries and around the world, the application. And eventually, when we have these boundaries, we want to distill what's the core domain, so we can implement what's the business differential, and maybe we can buy the rest. What makes sense, right? This is very typical business decision. Along the way, we need to encounter something that's called ubiquitous language. It's something that it's a language of the business that is common on everywhere we touch. It is depending of the boundaries, but the language here is very important, that everybody's on the same line. In the end of the day, we want to build a model of the domain, which is just a shared understanding. And this shared understanding, it's the main focus today. Okay, yeah, why functional and why Gleam? DDD is great, right? But it was origined in the object-oriented environment. And although these people that are doing great work, they have huge merits, and they do solve real problems, it is still dominated by object-oriented languages. Even the language to describe DDD is still object-oriented at most. In my opinion, they have a great idea, great initiative, not so nice tool for the job, but they get it done. What I like is the type functional approach. This is why you see this white book in the side, Domain Model Made Functional. It shows you a way how to use types to convey meaning. And you also have the how to design programs. It's not so typed, but still a very good reference on how to design programs in functional languages. But the idea here is we want to get into an accurate domain representation. And this is the strength of the type functional approach, in contrary to OOP in most cases, because we can be more direct and we can get there with more the type expressed very closely to what the reality is. And we can get very close and very pedantic if you want to. And why Gleam is, yeah, it brings to the beam, and now I'm unlocked with all the possibilities of the runtime. And not necessarily the beam, but the front end as well. And it can go on and on and on. One caveat though, when doing domain-driven design in functional, it's not the same, or at least to my opinion, it's not the same as type-driven development. Because what we want to focus is on the business cases. To answer the question, what kind of types I'm going to need, I'm not going to start with the data. I want to start with what is business operations. So in my opinion, this is what differentiated is, not data type first, but operation and deriving it. And funny enough, I was learning this kind of approach when I was also learning Elixir around 2 to 3 years ago. And two things go to different directions, and was very frustrated with Elixir because I could not apply these things, although I could, not in the same way at least. So I had to conform myself to not do this way in Elixir. And then I found Gleam, which was a refreshment. I will give you now a conceptual example, like a to-do app, which is taken directly from Scott Blashin's talk about this. And the way why I'm bringing this here very closely is because it's very successful at explaining the first step and understanding this kind of thing. So if we go in terms of modeling a card game, let's say a poker game, we can identify a few things like with types and say, hey, these are the available suits from usually Spanish card deck, right? Or French. We do have a set of ranks that we can apply to a game. And when we compose this together, we have one type. It's a card. It's a compose. It means it's a combination of rank and a suit. It is a meaningful thing here. And it's a new name for this combination, right? And then along the way, we get a hand, whichever player has. It's just a list of cards. So it's very easy to infer the meaning explicitly what it is. We also have a deck, which also is a list of cards. And they are structurally the same thing. Semantically, they're completely different. And I could even go further to say, in a card game, really, there is even a shuffle deck. Because there is an action, there is a business case, there is a workflow to say, eventually, I'm going to shuffle this deck. And what I usually get in is a deck, and what I get out is something very different. I'm changing it. And the meaning changes as well. And it is explicit and relevant to somebody who's getting in. Well, when we expand, we go to the game, and we have to see what defines a player. It's a name, and it has a hand. We go to the game. A game starts with a deck and a list of players. And around the game, we deal the cards, right? We have the shuffle deck. It implies already it has to start with a shuffle deck, and it just gives you a card over it. And as a player, when I want to pick up a card, I already have my hand. I pick up this card. Ta-da! My hand is back there. Pretty basic, but the focus here is optimizing for the sharing and understanding. I don't care about implementation, right? This is something that would come out with a collaboration with a business analyst of some sort. It is good that it looks like pseudocode. Yes, this is what I want. And yeah, if you would be critical, yeah, there's some analysis there. We could be more specific, but I don't care about it now, at least in this stage. So what happened here at all? And what I want to bring attention to you. Elementally, the code is documentation, so no more UML diagrams to try to convey the lossy conversion about the domain if using other tools. So the implementation will derive from it eventually. And if the implementation is not possible, your domain is probably missing something. Also, it's accessible for non-programmers. I can hook up my code editor with Gleam and try to model some data and try to model the ideas in a way that, of course, there is still some syntax to be accustomed to as a non-developer, but it's really small stuff, and you really have very good constraints to represent what's possible. And I can also show this to a business analyst, and you will say, wait, this doesn't work here, right? And I don't have contamination from framework databases. It is really, domain here is self-evident. Even in the implementation and the edges, it will spill out from the core domain, right? We talked about Squirrel before. I will put Squirrel in the edges. I don't want ORMs either. It's also very easy for programmers to understand because it's explicit in your face, and it allows you to ask questions if you don't understand. Now, have you noticed what happened here, right? If you go technical, the type theory stuff, very basic stuff, but yeah, the first type here, a suit, is really an union. It means in algebra an OR, it's an option, alternative. This tuple here is just a product type. It's a combination for many things. And I have the player name, which I don't care to define right now. It's nice that Gleam allows me to do that because it just gets out of the way. I don't want to say it's a string. Maybe I don't care. A game is a product type. It's a combination of data. And the implicit function signature is a type. We don't have interfaces in Gleam, right? But this is implicit there, and that's why also in the previous session I annotated this and kind of what would a type look like in terms of meaning. But what's important here, I'm using types to convey meaning, and I can opt in to use hidden types or new types to double down to restrict states that I want to limit to not be able to be represented. I'm composing types to represent data. Yeah, this is what we had a talk in the front end. With Gleam in the front end, we have Duster. This is basically how we approach things. And the choices are there explicit, the data structure are there explicit, and the use case or business rules are simply functions here. In this case, shuffle is a pure function. It states very clearly what it takes in, what it takes out. Maybe it doesn't tell me why it's there, but at least the functionality is clear. And it's kind of a workflow in terms of the core domain. Now, I will move on to a more familiar example, because something that is more relatable. I will model a cafe order. And this would be like the naive implicit workflow that we probably do with other programming languages, or if you are not accustomed to use this kind of thinking, we would deal with. For example, just order here, I'm mapping what an order contains. It has a list of items, it has a status. Usually you have like the mutability aspect of how the object passes around, and then you have the pay, the start preparation. Maybe we use aliases in the variables, like name, string. Oh, I know this string is a name now, right? It is useful, but it's still implicit. Everything is implicit. So you have to take runtime checks. There's no really guarantee, an explicit one telling you, yeah, I cannot start a preparation if the order is not paid yet, right? It's not there. Of course, an experience with a Gleam programmer would be have the sensitivity to not do that way, but we all have written this at some point, and there is string status and hope, right? So every workflow function accepts any order, and the errors are just caught by tests or live. So if I would make it in a more type explicit workflow, what it would look like is like this. I'm putting, for the starter, I'm putting the types of beverages as onions or alternatives, the sizes alternatives, and modeling what an ordered item is, which is, in the type, it's telling me what it is. I don't need the labels at this point, just removing stuff. But it's very obvious that this has a ubiquitous language meaning. When I have different stages, I'm borrowing the OOP name for what the OOP people call type state in terms of records, but I'm also delimiting for each stage of this order, it's be a different kind of data. Here I'm doing it very naively, right? I'm not trying to structure it well. I just want to show more what contains what and how we extend along the way. Where the business workflows as pure functions here, it is telling me with the types, without labeling and everything, what is involved there, right? So what's explicit here, the states are the states, like I start with a placed order, and then I get it to paid, and then I get in preparation, it's get ready for pickup, and it's get completed. I mean, start preparation can only take placed order, at least until a developer changes this. But of course, it's oversimplistic and will be expanded during implementation, and this is very naive. But the point, for the starting point to getting started, to double down and what is the minimum amount of work I have to do next, this is excellent. Because we can show this to everybody. And once they're familiar with the syntax, even non-technical person will come and say, yeah, even I can understand this. I says, hell yeah, this should be the case. Now I'm going to hint at the model's evolution, because what we have just sketched now is the inner circle, and what's in namespace domain, right? And the data and the workflows as functions. We want to keep it outside, call it functional core, imperative shell, or call hexagonal, I don't care. But the idea here is that there's much more to consider. Maybe in your domain, there are errors that are relevant to the business that you might want to get in. There is performance concerns using higher kind of types, or you want to use aliases in terms of data processing. Applications imply side effects. This is what they are. So you're going to have to deal with infrastructure errors. You're going to have to do some kind of dependency injection or something similar. You want to keep it at the edge as much as possible. So you're going to have results, types, and eventually. And yeah, apply what makes sense here, right? Maybe if your domain is just a state machine and a front end, yeah, you don't need to do all this stuff intrinsically. But now you have 5 developers with an application that has hundreds of modules. Yeah, this is life-saving. So use it with caution, but please explore it. Now, I have to give references from this because it's not something from me. I can recommend you anything from this gentleman. He's really a great communicator for that, from the F# community. Just go there. This is just, again, making your toes wet. Just go there and take that in and apply it to Gleam. There's other books like How to Design Programs. There's also DDD and FP discussions happening in other conferences in EU, which are very funny as well, right? And this is a link to Scott Blushing, basically talking the same thing as I am. Yeah, thank you. Thank you for making Gleam, bringing that to the beam, and making myself always coming back to it when I need to design domains. Thank you.